You know, for centuries, when you thought about military power, you probably pictured bigger ships, faster jets, stronger tanks. But what if that's all changing? See, artificial intelligence and robotics, they aren't just creating a few new weapons. They are fundamentally rewriting the entire rulebook of war.
So, I want you to start with this question in mind. Just for a second, forget about the single billion-dollar aircraft carrier. Instead, I want you to picture a swarm, thousands of small, cheap, autonomous systems, all working together like a single organism. This is the core idea that is absolutely shaking up military strategy today.
And this idea has a name. It's called mosaic warfare. And honestly, this analogy is perfect. Think about it. A single big painting is beautiful, but it's also incredibly fragile. You damage one part and the entire piece is pretty much ruined. A mosaic, on the other hand, is made of thousands of individual tiles. You can lose dozens, maybe even hundreds of them, but the overall picture, it's still there. That's the goal here, to build a force that's just too numerous and too spread out to be defeated by a single knockout blow.
Now, what's so fascinating here is the massive shift in thinking this represents. The old way, what they called network-centric warfare, was all about one thing: getting perfect, godlike information to a central command hub. But the new model, decision-centric warfare, is way more realistic. It accepts that in a real fight, networks are going to get jammed and communication is going to fail. So the most important thing becomes empowering the commanders on the ground, both human and AI, to make faster, better decisions with whatever information they have right then and there. And this quote just nails it. It's not just about making ourselves faster. It's a two-sided coin, right? The goal is to speed up our own decision-making process, while at the exact same time, you're trying to completely overwhelm and degrade the enemy's ability to think, to communicate, and to act. You want to get inside their decision loop and just tear it apart.
Okay, so we've got this revolutionary concept. It sounds great in theory, but how do you actually figure out if it works? I mean, you can't just go start a war to test out a new idea. And this is where wargaming comes in.
And that's a huge challenge, isn't it? We're talking about trying to simulate future conflicts, maybe against an enemy that's just as powerful as you are, using systems and technologies that are barely even off the drawing board. The answer really is to create these incredibly sophisticated digital sandboxes where you can play out these future scenarios over and over again.
And you know, this isn't some secret, abstract process that's locked away in the Pentagon. The basic ideas behind it are surprisingly common. There are actually commercial, tabletop role-playing games out there that let you simulate things like counterterrorism operations. It just goes to show you that the core concept, using a game to explore really complex choices and their consequences, is something we can all understand.
But when you get to the professional level, oh man, the stakes get so much higher. As you can see here, military planners are using these war games to answer these incredibly complex strategic questions. They're not just moving pieces around a board. They are modeling everything from how a cyber attack could affect a physical battle all the way to the total economic cost of a campaign. They're trying to find that perfect balance of forces long before any real conflict ever begins. And behind all of this, we're talking about some serious computational horsepower. These are not simple games of chance. They are massive, massive simulations, running thousands of digital battles, using these advanced algorithms to model every variable you can possibly think of. It's really about using data to game out the future.
All right, so we've talked about the theory and we've talked about the simulation, but how do you actually go from a digital model to a real-world blueprint? What does it even look like to start engineering one of these futuristic mosaic forces?
Well, here's a fantastic real-world example. The U.S. Chief of Naval Operations basically gave students at the Naval Postgraduate School this exact homework assignment. Now, the jargon is a total mouthful, but the mission itself is pretty clear. Design a new kind of naval force made of a mix of manned and unmanned systems that isn't reliant on a few big ships, and its job, to deny an enemy access to a critical piece of coastline.
And their approach was incredibly methodical. First, they had to define what success even looked like. Then, they analyzed hundreds of existing unmanned drones, in the air, on the surface of the water, and underneath it. Then, and this is so important, they created a scoring system to grade each one. Finally, they took the best combination of these tiles and threw them into a combat simulation to see how this new mosaic would actually perform under pressure.
So here it is, the million-dollar question. Does the theory actually hold up when the digital missiles start flying?
The results from their simulation were, well, they were fascinating and absolutely not what you might expect. This chart shows the percentage of enemy forces destroyed. The baseline force, 2 traditional big destroyers, was way more lethal.
It destroyed 96% of the enemy. The new unmanned swarm, it only managed 38%. So on the surface, it looks like a total failure for the swarm, right? Well, not so fast.
And this is the key insight. Yeah, the swarm had way less raw kinetic firepower. But, and this is a huge but, because the force was so spread out, it was far more resilient and survivable. Having more eyes in more places meant they could find the enemy just as effectively, even if each individual drone's sensors were a bit weaker. So it's a trade-off. You're swapping some lethality for a massive gain in survivability and resilience. Okay, so let's be clear. This isn't all just theory and computer models. The actual building blocks, the tiles for this new mosaic, are being built and deployed right now as we speak. Take a system like Prism. Think about it. Having a human being try to watch dozens of video feeds at once, it's exhausting, it's impossible, and you're going to miss something important. This AI system does it automatically. It analyzes multiple streams from all kinds of different cameras to detect and flag threats in real time. It's not replacing the human, it's augmenting them, letting them focus on making the critical decisions.
And then, of course, you've got swarm drones. The real magic here isn't just the drones themselves, it's the AI that connects them. These drones don't need a human with a joystick controlling every little move. They talk to each other, they collaborate, they work together to accomplish a mission. I mean, they are the very definition of a redundant, resilient system. Situational awareness is also getting this massive AI boost. This system is just incredible. It uses AI to stitch together video from multiple cameras all around a vehicle into one seamless, 360-degree view. It completely eliminates blind spots for the operator, basically giving them a godlike perspective of everything happening around them. And the list just keeps going. I mean, we're seeing autonomous patrol boats, facial recognition tech that can see through disguises, real-time language translation for intelligence, and even smart helmets that use AI to literally map the inside of a building as a soldier walks through it for the first time. Every single one of these is a powerful new tile for the mosaic.
So let's just step back for a second and tie all these different threads together. What is the ultimate impact of this whole revolution on the battlefield and maybe more importantly, on the humans in command?
At the end of the day, it all comes back to this one central idea. We are witnessing a historic shift away from the big, expensive, and fragile platforms of the 20th century and toward a new kind of force that's spread out, intelligent, and can be endlessly reconfigured on the fly.
But, and this is probably the most critical part of this whole conversation, it doesn't remove the human from the equation. It just changes their role entirely. The future is a partnership. It's a fusion of human command and strategic oversight with automated, high-speed machine control down at the tactical level.
And that leaves us with this ultimate mind-bending question. In a world where AI can manage a swarm of hundreds of units, process intelligence, and execute commands in microseconds, what is the new role of human leadership? What does it even mean to command when your soldiers are algorithms and your battlefield is a network? That's the challenge that an entire generation of military thinkers is grappling with right now.